Welcome to an introduction to quantitative comparison questions. In this lesson, we'll examine the structure of this unique question type and the four answer choices that always accompany the questions. Now, when you write the GRE, the first 7 to 9 questions in each math section will be quantitative comparison questions. Given this, it's crucial that you become adept at solving this question type efficiently and correctly. Now, you'll soon find that quantitative comparison questions typically take less time to answer than other math questions. So you should allot approximately 1¼ to 1½ minutes for each question. Okay, let's take a closer look at these questions. To begin, each question consists of two quantities, quantity A and quantity B. Your job is to compare the two quantities and choose answer choice A if quantity A is greater than quantity B, answer choice B if quantity B is greater than quantity A, answer choice C if the two quantities are equal, and answer choice D if there's not enough information to determine the relationship between the two quantities. Now, it's important to note that these answer choices are the same for each and every quantitative comparison question on the test. I should also mention that on the day of your test, you will have 4 radio buttons, and you must select one of them for each question. You will find, however, that most GRE resources label these options from A to D in order to refer to each of them. Okay, let's try a few questions so that we can get acquainted with the answer choices. The first one is pretty straightforward. When we evaluate quantity A, we get 21, and when we evaluate quantity B, we get 24. Since quantity B is definitely greater than quantity A, the correct answer here is B. Here's another one. For this one, when we evaluate quantity A, we get 49, and when we evaluate quantity B, we get 49 as well. Since the two quantities have equal value, the correct answer here is C. Here's another one. As you can see, this question contains additional information about the heights of Kyla and Glenn. Any information that appears in this location is shared information that can be applied to both quantities. So here we're comparing Kyla's height with 68 inches. To solve this question, we should first recognize that if Kyla were 70 inches tall, then Glenn would also be 70 inches tall, since their heights must add to 140 inches. In this scenario, Kyla and Glenn would be the same height. However, since we're told that Kyla is taller than Glenn, it must be the case that Kyla is taller than 70 inches. Now, we still don't know exactly how tall Kyla is, but that doesn't matter, because we now have enough information to compare quantity A and quantity B. If Kyla is taller than 70 inches, then her height must be greater than 68 inches. As such, quantity A must be greater than quantity B, which means the correct answer here is A. Okay, one last example. Here we're given some information about x. We're told that x squared equals 25. Given this information, there are two possible values for x. X could equal 5, in which case quantity A is greater than quantity B. Or it could be the case that x equals -5, in which case quantity B is greater than quantity A. Since it's impossible to determine which quantity is greater here, the correct answer is D. Okay, that concludes our introduction to quantitative comparison questions. Let's summarize. In this lesson, we examined quantitative comparison questions and the 4 answer choices that always accompany these questions. In upcoming lessons, we'll examine a variety of strategies for handling this unique question type. In this lesson, we'll examine some strategies to consider when answering quantitative comparison questions. These strategies involve approximation techniques that can help us solve questions quickly. At the heart of these techniques lies a very important rule. Do not perform more calculations than are necessary. Remember, the GRE is not meant to test your ability to perform tedious calculations. It's meant to test your number sense. So if you find yourself carrying out lengthy calculations like this, then you're probably wasting time. In many cases, we can avoid time-consuming calculations and use one of the approximation techniques covered in this lesson. Now, the first technique we'll examine uses some simple estimation with a twist. Consider this question. To solve it, we'll apply the formula for finding the area of a circle. Since the radius of the circle is 5, the area will equal pi times 5 squared, which evaluates to be pi times 25. Now at this point, we could replace pi with approximately 3.14, and from here we could multiply 3.14 by 25 and then compare the result with quantity b. However, this would be much more work than is necessary. Instead, I'd like to introduce you to some notation that you'll see throughout this course. Rather than replace pi with 3.14, we'll replace pi with this. Here the floating plus sign tells us that we're dealing with a number that's bigger than 3. From here, we can see that if we take a number bigger than 3 and multiply it by 25, we get a product that's bigger than 75. And if we compare a number bigger than 75 to quantity b, we can see that quantity a must be greater. So according to the answer choices, the correct answer here is A. As you can see, we were able to solve this question without performing any lengthy calculations. This will typically be the case with GRE math questions. Now, when it comes to using approximation to solve quantitative comparison questions, another useful strategy is to compare the quantities in parts. Here's an example of how this strategy works. As you can imagine, we do not want to add all of these values together. Now, we could try using approximation here and see if that works. However, we can solve this question even faster by comparing the two quantities in parts. Here's how it works. Let's first compare these two numbers since they're relatively close in value. As you can see, this number is bigger than the other. When we compare these two numbers, we can see that this one is bigger. And finally, when we compare these two numbers, this one is bigger. So all three numbers in quantity A's sum are greater than all three numbers in quantity B's sum. As such, quantity A must be greater than quantity B, which means the correct answer here is A. Okay, let's try another question. Now you may want to pause the video and try this one before continuing. Okay, what should we do here? Well, we might begin by recognizing that this fraction is very close to 1/2. Now, is it bigger than 1/2 or smaller? Well, 125 over 250 equals 1/2. So 123 over 250 must be less than 1/2. So we'll replace this fraction with a number a little bit smaller than 1/2. In this instance, the floating minus sign here tells us we're dealing with a number a little bit smaller than 1/2. On a similar note, this other fraction is very close to 1/3. Now 3003 over 9009 equals 1/3. So 3003 over 9047 must be less than 1/3. So we'll replace this fraction with a number a little bit smaller than 1/3. When we apply similar logic to quantity b, we see that this fraction is a little bit bigger than 1/2, and we see that this fraction is a little bit bigger than 1/3. From here, we can compare the quantities in parts. When we compare these two fractions that are close to 1/2, we see that this one is bigger, and when we compare these two fractions, this one is bigger. Since both numbers in the quantity b sum are bigger than both numbers in the quantity a sum, quantity b must be greater, in which case the correct answer here is B. Okay, let's look at one last question. For this one, we'll apply a useful technique at the very end. Once again, you may wish to pause the video and try the question before continuing. Okay, first let's replace these cumbersome values with nicer ones. This number is a little bit bigger than 130,000, so let's write this. Similarly, this number is a little bit bigger than 480,000, so let's write this. In quantity b, this number is a little bit smaller than 260,000, and this number is a little bit smaller than 240,000, so we'll write this. From here, we can see that all four numbers end with 4 zeros. So let's just drop those zeros and compare these simpler values. Now at this point, you could choose to multiply these values and then compare the two products. But there's an even faster approach that you can do in your head. It involves a useful rule that we'll examine in a different module. it says that the product of A and B is the same as the product of 2A times 1/2 B. Now, why would we want to apply this rule here? Well, notice that if we multiply 13 by 2, we get 26, and when we multiply 48 by 1/2, we get 24. This suggests that our rule here might make our two quantities look more alike, and this could come in handy. So to apply the rule, we'll multiply this number by 2 to get a number a little bit bigger than 26. And then we'll multiply this number by 1/2 to get a number a little bit bigger than 24. From here, we'll compare the two quantities in parts. When we compare these two numbers, we can see that this one is bigger. And when we compare these two numbers, we see that this one is bigger. Since both numbers in the quantity A product are greater than both numbers in the quantity B product, quantity A must be greater, in which case the answer is A. Okay, that concludes this lesson. Let's summarize. In this lesson, we learned 3 things to consider when tackling quantitative comparison questions, and we learned some special notation that helps us when using approximation.